Good afternoon, everybody. Thank you for joining us for our second webinar of the year. We have these planned through, I think, June at this point. And so our goal is to bring you sort of a new, fresh topic every week or so, give it some holidays, maybe every other week in some cases, but really to highlight a lot of questions that we're getting asked from customers, feedback that we're getting in our executive briefings, and just highlight areas that we feel you all can benefit from. So really privileged to be joined today by Jad Al-Zain, one of our principal technologists from the VCF division. My name is Rob Regal. I'll be host today. I am the head of our customer success organization for our U.S. federal business. And so we welcome, to the webinar. We'll get started here in just a second. I'll hand it over to Jad. Just a couple of housekeeping items. We do encourage questions. Please let us know any questions in the chat. We would love to hear from you. And there will be some surveys that'll pop up, one at the end, and then you will get an email. We would love to hear from you. Any feedback, future topics you're interested in, shorter, longer, better hairstyles, whatever you got, we will take it. And with that, maybe Jad, platform engineering for mission critical clouds. It's an exciting topic. I will hand it over to you, my friend. Thanks for doing this for us.
Thanks, Rob. I agree with just about anything except for the hairdo comment. I think I'm sticking to this one. Um, so yes, thanks all for joining, taking time out of your day. I am Jad Al-Zain. I'm a principal technologist at VMware, been 16 plus years. And previous to that, I was actually at Lockheed Martin for 11 years as an architect. And really that move as a data center architect is what brought me into VMware, and the rest is history. So I'm really happy to be here, and this is probably a topic that is not something that you regularly see in your average VMware catalog of topics and webinars. So it has been top of mind for us, and it has been something that I've been spending a lot of time on. And so what I'll do is really break down what it means to be platform engineering or a platform engineer, and considering the audience, what it means for technologists and practitioners from a VMware background to make the move into platform engineering if you haven't already, right? Or what we also hear is like, hey, a team called platform engineering already exists and they already have their ways. As platforms merge and converge and change and stuff, how do I become an extension of that? We get all kinds of things. But what I'll do is really spend more time about what platform engineering means, the value, the benefits, and where VCF plays a role. Again, VCF is not the first thing that pops to people's minds when they think about application platforms. So hopefully I will change your mind after this session. All right, so getting started into the content. We have our challenges, right? This is just a setup slide here. There's different personas and different roles in each of our environments, right? You've got your typical enterprise admins. This happens to be what I was when I was supporting DoD and DHS. But at the enterprise admin level, you're focused on the I guess keeping the lights on, but keeping the lights on the servers on, right? You've got your physical infrastructure, your storage, your network, your multi-tier architectural components inside of a data center or cloud, or stretched across data centers, and again, or in my case, afloat on a Navy CDN, right? So regardless of where that architecture lives, the enterprise admins are responsible for like the day-to-day. It is the stuff that runs. And there's as we start thinking about the demand, right? So all these are aligned with the demand. The demand is overwhelming, right? We need to maintain and manage traditional infrastructure, mission critical infrastructure, infrastructure for specific missions, but also this vast array of different runtimes and services and capabilities. And what's happened in the past is this has been divided up into silos and different teams. But more and more, those architectures are converging. So now we've got enterprise admins trying to figure out how to support all infrastructure, which includes Kubernetes, which includes AI workloads and inference, and how do I manage all of that? So there's an overwhelming component there for the traditional enterprise admins. And the enterprise admin is a that vast component of all of this in terms of cloud, right? The tenant admins or the mission admins, however you want to call it. But the tenant admins are, have a very specific scope in which this could be a line of business, this could be a business unit, it can be a particular mission or a particular objective. These folks have limited scope, limited visibility, or specific scope, limited visibility. So their control over what's happening at the lower levels of infrastructure could be limited. Sometimes it spans, but it could be limited. And so delivering the needs of the particular mission becomes more and more difficult, especially as all this other churn is happening in the background. So now we're moving into the application space where we have your platform engineers and your devs or your DevOps engineers. And the platform engineers, whether it is a named team or not, the function probably does exist in most environments. And the platform engineers have to deliver services to the consumers. These are, in this case, the developers, the folks who are building applications that are gonna get provisioned downstream, that are gonna run in a tenant or multi-tenanted on top of the infrastructure supported by the enterprise app. So it's the whole workflow happens there. But what the platform engineers are most challenged with is which tools do I use to perform which tasks, who has access to those, and how do I align all of this with the enterprise so that when I am delivering my services, regardless of what that service looks like, it is aligned, it is secure, it's compliant, and it delivers, it delivers the apps, it delivers the goods. And what the platform engineering or what the platform engineer's core product is called an internal developer platform. So look at the platform engineering team as a manufacturer, and they manufacture something called an IDP. And that's really what it comes down to when we talk about platform engineering. And then, of course, the consumers are the customers. They are the ones who need the platform engineers to deliver this service. So that was kind of just a quick primer. We'll talk a little bit about how we got here. Just building this out real quick. So application delivery has changed drastically since we all became professionals in this field. Actually, it doesn't even matter when you became a professional in this field. It probably has changed since then, whether that's last year or a decade or 2 decades ago. And it's constantly changing. That is really the only constant here. And so, initially we followed this linear model called waterfall, where requirements were defined up front, software was built and tested, and it was done in sequential phases. And it worked for the majority of the time. And it kept up for the most part with the systems and services that needed to be delivered. But it also introduced a significant amount of complexity. And so to respond to that, we needed to be agile. We needed too much, the waterfall wasn't agile enough. So everybody wanted to be agile. So DevOps came up. And DevOps is self-explanatory. It's the beauty of it. It's breaking down these silos that created the complexity and bringing together your development teams and your operations teams. And so with that, you gained automation, you gained continuous integration and delivery, you gained a culture of shared responsibility. So these teams now say, okay, look, I can't point my finger at you. You're not going to point my finger at me. We're in this together. And it was a huge leap forward, but still largely operated within the constraints of your traditional infrastructure, right? So the methodologies were very similar, but we have teams coming together, which definitely pushed things forward. So new innovative ways on how to accomplish a task was an outcome from that. And then, of course, hyperscalers took over. The public cloud ate the world, and something called Kubernetes started happening. And that was about a decade ago. Now, Kubernetes was created to solve a hyperscaler problem, and it was created by hyperscalers, namely Google. And so, in this cloud native era, applications that initially took advantage of it, and still today, they were designed for elasticity, for scalability, for resilience from day one, right? They were made up of microservices, and they were built largely to be run on top of Kubernetes and cloud native services. So all the other services that popped up across these public cloud providers that had specific or very niche capabilities or services like storage or S3, IDP, and so on, right? And all of this was deployed with this new methodology or an evolving methodology called GitOps. And it made things not just faster, but fundamentally more adaptive, right? So we went from like slow and fragile to agile and self-healing. And this is kind of where we are today. So great. The public clouds are there. We take advantage of them. We saw this huge shift into public cloud. But what's happening more recently? We have AI bringing data back on-prem. We have data sovereignty being a huge push to bring private clouds back into the mix, or reinvest in private clouds. And so, there's a little bit of hurt there because we're saying, well, we have gained all of these benefits from taking advantage of these the cloud native and microservices architectures and GitOps practices. Yet I know I need to move to private cloud or have even a completely air-gapped infrastructure. How do I gain or bring those capabilities into my private cloud? And there's a couple of players in here. And to name two, there is VMware, and there is others like OpenShift and so on. The goal isn't to just be another infrastructure provider. Again, VMware has done this for 2 decades. Kubernetes, we've done this for a decade. For as long as Kubernetes has existed, we've been running containers on vSphere. So there's a much more to think about than just that, and I'm gonna step you through that in the next few slides. Now, by the way, this session is designed to be educational as well as informative. So, do feel free to bring questions into the Q&A, and I will do my best to answer them. And if I can't answer them here, probably because it's going to be a long answer, I will follow up for sure. All right, so again, before platform engineering, so we talked about the software methodologies and development, different methodologies that happened over the years, but now we need to encapsulate what we are talking about. And that is, again, where platform engineering comes into play. So before platform engineering, it's kind of a mishmash of methodologies. There's no set way of doing anything except that, across the industry, that is, except for what are the individual needs of an individual enterprise or mission or capability. So whatever worked for the particular organization essentially was implemented. So again, we've got the methodology that we want down: cloud native services, GitOps. Cool. Implementing that is where we are now. So looking at code to production, right? This is specifically where platform engineering came to play, and it is designed, and platform engineering teams are challenged with taking that code to production, regardless of which code and whatever is called production and everything in between, and say, this is the path you will follow to accomplish these tasks, right? It brought ownership, it brought responsibility, and it allowed me to very quickly be able to get in front of potential pitfalls, any associated risks, and then manage accordingly. Now, taking advantage of all these modern techniques through GitOps, through open source, through the tools that are available out there, but this is the people problem that we're looking at specifically here. So we've got our infrastructure, we've got our observability requirements, we've got our automation requirements, and then of course we've got our compliance, security, scalability, and all those other things that we expect from a public cloud that now need to be implemented in a private cloud. So to break this down into 5 key principles or 5 key trends, when we're talking about platform engineering, these 5 things really stand out as like you have to address this before you can, build the deliverable, which is the IDP. First of all, we know Kubernetes is the de facto. Now, I say modern apps a lot, and almost instantly everyone assumes I'm talking about Kubernetes or cloud native. It's not necessarily true. I actually try to separate those. A modern application is essentially any application delivering a modern workload, right? Or any workload delivering a modern service. It could be a VM. Absolutely. It could be serverless. It could be running in a container, or it can be running on a Kubernetes cluster. More often than not, it's a combination. It's a hybrid runtime. So what we have seen, again, more often than not, is you've got your virtual machines, your VM-based, your OS-based VMs that have just been around forever, and they continue to evolve, and they continue to be updated, and so on. But they are monoliths at the end of the day. And then what we see happen in the last 5 years or even 10 years is like the front ends get spun up into a microservice. Maybe we take move the data to a specific data provider, change the storage architecture, change the way that the file services associated with that VM, and all of these are moving to more modern cloud native services. But it's all a modern app. And VMs and Kubernetes and containers and native services will all continue to play a role in this. So with all of that said, in platform engineering, right, because we're talking about microservices, because we're talking about like this hyperscaler driven architectures, Kubernetes is absolutely key and central to all of it. So we'll see Kubernetes become the de facto, and in a lot of cases, it is the de facto. In certain areas, especially in areas like Fed or SLED, and specifically in Intel and DoD and others, we see different rates of adoption based on risk assessments. So Kubernetes and containerization actually in Fed actually trailed what startups were doing, because that's of course expected. There's a lot more validation and trust to be developed there. So we see Kubernetes becoming de facto for production today, across all these verticals, and I think that's here to stay. But who knows? It's only been a decade. The other thing we're dealing with is in platform engineering is multiple platforms. So typically you have your infra platform running your VMs and OSs and your traditional, we'll just call it your quintessential VMware stack, right? Your virtualization stack, cloud management, and so on. Then you have your app dev stack. So think your developer tools, developer portals, and Kubernetes runtimes there. Now, Kubernetes is infrastructure. So it's weirdly bundled with modern app and app stack. Kubernetes is infrastructure. So let's just be clear there. But that is what the industry has done, right? What developers have done is they bundled the runtime as part of their app stack when it really should be separate. So we have these multiple platforms, and more than ever, we're saying like, look, we need one platform. We can't keep doing this. So 2 things to do. One is have a path to production in each of these platforms or some combination, or consolidate platforms. Now, VCF, obviously, we position to consolidate platforms, and VCF being your go-to, but of course, that's easier said than done. And there's a lot of opinions, right? So we see less and less from the developer side, but more on like the platform teams, the SREs, the GitOps admins, the DevOps admins. They're very opinionated in which tools and how it needs to be done and what needs to be support, to be agile enough to deliver my code as I need it delivered and as quickly as I need it to delivered. Then of course you have the opinions coming from the infrastructure stack, your InfoSec and CISOs and those, and there could be mandates, but some of those mandates get lost in opinion, and that's where things start to break down. I think everybody on the call could agree that that has happened, right? And share stories probably. I still have battle wounds from that. But also tools that have just gone out of control, right? Multiple tools doing the same exact thing. Again, in certain verticals, we see some controls in which tools can be run. That is certainly one of those verticals, and DoD specifically. But at the end of the day, we've seen increased adoption of open source and other tools being part of this code to production pipeline, and those need to be addressed as well. So now, with all of that said, how do I start bringing this house in order? And it is, we talked about platform engineering. The key deliverable there is the internal developer platform. And in the internal developer platform, or what that deliverable is designed to bring, is something called a golden path. Now, a golden path is not a mandate, it's not a template, but it is my deliverable. It is, the IDP, which is how you get the golden path, is your deliverable, right? And so it's treated like a product. It evolves, it's versioned, it goes through various iterations. It's not, set and forget in a lot of cases, because it in itself has to be as agile as the needs of the applications as those needs evolve. We're not talking about daily change, but if so, why not, right? So the golden path here takes a little bit of an opinion and says, look, to deliver code to production at the need of your mission, this is the path to get there. And that's essentially what it is. The whole purpose in life for an IDP is to deliver that path. And what we accomplish there is very consistent infrastructure, or very consistent processes, very consistent outcomes, and known outcomes, right? No surprises, and consistent code to production, which is really what all of this is about. This is all about delivering that application. And the golden path for mission critical clouds just means that I'm reducing things like, okay, what are the choices? What are the options? Which versions work? How is this supported or not supported? When does security and compliance play a role here? And so on, right? We've got, a lot of reason to adopt a solution to solve problems, but we could also potentially introduce new problems. So the idea here is to eliminate the complexity associated with, like, either everybody has to do the same thing or everybody's on their own. This is really bringing in a path for a particular mission or a particular desired outcome. And that's what the IDP, or the golden path, is essentially trying to do. And your gains here are faster onboarding. You've got your buckled down security, consistent observability, where I'm not only being able to observe my environment, but because of how my IDP or my golden paths are defined, I know that anything that gets implemented in this environment, I'm going to have immediate visibility into. Nothing's hiding because an agent didn't get pushed, or because the observability stream isn't flowing back to my tools and so on, right? It's all done consistently, regardless of the runtime, the platform, the number of nodes, and so on, right? Or the code that's being used. So this is the big outcome here, is this consistency. Okay. Now we could expect what the outcome is going to be, and then we could measure, and we can close loop iterate. So as I'm measuring the outcomes, as I'm defining, what I expect from this environment, whether it's hardening or performance or scalability, as I need to make changes, I'm taking advantage of these same exact tools to iterate and do what's called closed loop observability or closed loop iteration. So my IDP itself gets iterated along with the software that and or my code to production pipelines. So I'm constantly fixing and iterating based on the needs of the application and the mission. Okay, so how do we I just saw a typo. Not a paved cow path. It's a paved path. Um, so we identify the path. We define the contract. Again, we're building a product here. So we define the contract, and then we figure out how it all comes together. And I'll show you some examples here in a little bit here. So then it gets all wired in, and we call them guardrails. Guardrails are within the IDP. The IDP itself can sometimes be a guardrail, but really that's not its intention. These are guardrails inside inside the path. Call them railings, right? On a path, and then observability. All of this will fail without the appropriate levels of observability, as I'm sure a lot of you would agree. And so understanding what's happening, having the appropriate dashboards deployed, appropriate access to those dashboards, all being fed into the appropriate NOC tools and so on. And then you go ahead and launch that as a product. I'm actually going to skip that because I've already talked about why sometimes they fail, but essentially we can always get ourselves into deeper problems when we don't make some very fundamental decisions like which tools am I going to use and so on. So now, coming from a VMware environment, infrastructures played a huge role in assuming you folks on the call coming from a VMware environment, infrastructures played a huge role in our day-to-day and so on. And so as public cloud proliferated, and became kind of the dominant player, so AWS, Azure, GCP, and so on, we see all the benefits there. It really is an infrastructure play. At the end of the day, it was an infrastructure play. It was just somebody else's infrastructure. And suddenly, because it's somewhere else, I'm less opinionated and I'm not making vendor decisions and I'm not making branding decisions or the number of disks in a spin or in a RAID array or anything, those basic things. So I'm going to bring that back now that we're talking about I need that in my private cloud. So infrastructure and your infrastructure investment is more important than ever before. And so all of that seems like I'm further along than 14 slides, but I'm only 14 slides in. All of that to say, the decisions we make in the private cloud do not have to necessarily be so different than the benefits of the public cloud, the decisions and what we implement in the private cloud. So VCF has actually, led the way in as far as that goes. And again, I've been here for 16 years, and I've seen everything from all the different acquisitions and trying to piece together different products in VMware's history. And we did the SDDC and we acquired all these things and we said, here's a suite of products and here's a CMP, cloud management. And we've seen so much evolution and so many attempts to bring things together. But rarely were we able to say like, hey, this is a platform without kind of like hiding a grin or kind of trying to fool ourselves first. And that's just my unvarnished truth. Now, in the last 2 to 3 years, I've seen that evolution happen in ways that I've never seen here before. And as a customer, maybe you've also experienced the same. And so I've seen this integrated suite of products turn into what is VCF 9, which is truly a platform on so many different levels. And this is why I'm excited to be talking about platform engineering and we actually can talk about it now and follow through, right? And so when we say VCF as the platform substrate, another important thing is nowhere in here I'm going to say VCF is your internal developer platform, because again, I'll be laughed out of the room. That is not our goal, and that is not what we designed VCF to do. We did design VCF to be app-centric for your modern apps and whatever. And essentially what I said in a previous slide, it is your it's the foundation, right? It's the platform substrate. It's what everything is built on top of, so you can start gaining the benefits instead of piecemealing the whole thing together. So you're taking advantage of these core services that have been around for 2 decades that you trust mission critical apps on, still in the millions today, right? VSphere, rock solid compliance, 7 layers of security and hardening inside of the stack, starting from runtimes all the way down into how I address NUMA nodes inside my cores or inside my hardware. So there's deep like trust in vSphere, and what we want to do is build on top of that. And the rest of the stack, my networking and my storage all becomes just a core component here. So at the bottom of every cloud, you've got your underlying physical infrastructure, your compute, your storage, networking, and so on. Your runtimes on top of that, and then your cloud management tools and services to really polish things off around that. The platform has converged largely around application needs and modern app needs. And this isn't new, right? VMware has been running modern apps and containers for a while. I'll even spend a little more time on that. But when we're talking in the platform engineering context and an application platform, there's several different approaches. But the key factors here and how do I deliver services for an app is the interfaces must be cloud native. They must be composable and API first. Now, VMware, we've always prided ourselves in like, hey, we have this widget and we're releasing the API for it. Cool. Here's another widget and another API. And here's your platform, your compute platform, and it's got its own API. And it depends on where your entry point is, if it's ops or automation or NSX for networking. They all have APIs. Cool. But they were all different APIs. And we swagger them and all that stuff, but they're all different APIs. To get to a platform, just like you would when you're consuming public cloud, right? You want the one API, at least the one schema. And you want to be able to interact with that consistently, regardless of how how it's who's hosting it and where it exists. So we've converged on the Kubernetes API because it is how people want to consume infrastructure, and in vSphere or VCF9, that is essentially taken over as our primary interface for programmatic consumption of entire VCF and the workloads. Right? It's unified declarative API. Now, with that declarative API, I can start gaining all the GitOps components. So my pipelines, my Helm charts, my CI/CD, all of those things now are leveraging that common API, and I've started adding consistency, right? So this is today, right? This is VCF9 today, and certainly even more so moving forward. And now I have my observability tools that are built for Kubernetes. Your Grafana and Prometheus and all these solutions that out of the box are looking for that API that now just work out of the box for all my Kubernetes workloads and VM service workloads running in VCF, right? Zero trust. Now of course we want to benefit from what VMware has brought to market and its compliant platform and zero trust and what we've done for years. The compliance, we've helped define compliance in this industry. And resilience by design. A lot of this is core vSphere capability. And that all leads us to platform engineering as a foundation. So in VCF9 and moving forward, platform engineering is key. If we are delivering a product or solution that takes us off that track, we're doing something wrong. So we really focus on the messaging that I've shared so far for platform engineering. Now, I did mention that, hey, this isn't new to VMware. Kubernetes containers running on vSphere has been a thing for a really long time. And in fact, in 2018, when we acquired Heptio, we also gained the 2 co-founders of Kubernetes. They were VMware employees way back at 2018. And even before that, we were running containers on vSphere because it's a hypervisor and we could run anything on top of it. Right. But we are able to do it in a way today, fast forward, a way today that's not only just a Kubernetes runtime, but it's tuned specifically to take advantage of that substrate. The same reason that you run your most your most critical and mission critical workloads and largest, most scalable workloads on VMware today. Kubernetes containers, the same thing, right? So really, it's an extension of what we've already done. We're not new to this game. This isn't, and the reason I have spent already this much time on that is because some customers and stuff I've spoken to think that we're just getting into this. That this is something we are now trying to play catch up on, and that is absolutely, couldn't be further from the truth. So I did want to double click on that for a second. Has it been as prolific in our go to market in our messaging? No, it has not, and maybe that's one of the big changes. But anyway, I digress. So another thing, a big huge shift for VMware, because VMware in the past has been very opinionated, as probably everybody here agrees. Big shift in how we embrace open source, right? KubeCon in Amsterdam 2 weeks ago, 3 weeks ago, and Atlanta, and the upcoming India and Salt Lake. Right, KubeCon is now the second largest investment for VMware next to Explore. I mean, that's significant. That's very telling. And VMware has spent a lot of its history contributing to projects. We are among the top 5 contributors to the Kubernetes project and have been for many, many years, right? We recently donated projects like Valero to CNCF, right? There was a great press release about 2 weeks ago. Actually, we announced that while in Amsterdam at KubeCon. Projects like Harbor and Treya for CNI and Pinniped, Contour, like all of these projects were started by VMware, or at least today, VMware is a huge contributor to them. So again, it's in the DNA. That's the whole point of this slide. It's in the DNA. And when we talk about Kubernetes and these runtimes, it's not new to VMware. Again, that's the takeaway here. Now, what can VMware bring to the table when it comes to modern apps and Kubernetes? Well, we can't just say, yeah, we do it too, because that's not really exciting. So what VMware has done is said, okay, well, we're going to not just build the best Kubernetes runtime. First of all, it has to be upstream conformant, which means if it runs on Kubernetes, it runs on VKS. And that's brought to you by the vSphere Kubernetes service, which is out of the box part of VCF, right? We've added long-time support. So we're listening to customers. Where are the big complaints? And this is one of them. So for every release of VKS, so the Kubernetes Foundation or the Kubernetes project releases versions of Kubernetes. I think 1.3.5 is the most recent one. And then we release a VKS, which basically packages that all up and puts it in VMware. And with that, we will support N-2 and add 2 years of support for every Kubernetes release. And I'm sure some of you on the call right now are already understanding how that's going to help your situation, whatever it is, because this is a real problem. Support for Kubernetes falling out of support. It's a big problem. And the other thing we're going to do is we have an internal SLA. So for every Kubernetes release done by the Kubernetes project, we have it packaged up and ready to deploy into VCF within 2 months. Our SLA is like 53 days, which is second only to AWS in the whole industry. That's significant, right? And then, of course, fleet management across all of this, being able to do rolling updates, being able to either automate, do it totally programmatically, like lights out upgrades, et cetera, or do it through a comfortable UI for you who are way more comfortable in like a vSphere or automation UI, all of those things apply. And that's the VMware magic sauce that we add to this. It's familiar capabilities and processes on top of what would otherwise be very complex methodologies, right? And then on the left here, right, the end-to-end hardware integration. So when you're running Kubernetes on vSphere, you're not thinking about where am I getting storage from, where am I getting networks from, what about this, what about that? How am I going to lock this down at the hypervisor? It's all done. It's all there. You're taking advantage of what you already know. Your vSAN, your NSX, your compute, it's all there, right? And then, of course, it's streamlined and incorporated into all the tools you know and love, automation, and vCenter, and then beyond all of that, where the vast majority of the folks on the right moving into infrastructure, so like your DevOps and developers, they want to bring their tools, their GitOps tools, their Argos, their Helms, all of that stuff, and never log into a UI. Cool, not a problem, right? That API is there for you to do exactly that. And we actually deliver VKS and VCF as a whole with a whole bunch of packages out of the box. We've got standard packages and then core packages. These core packages are just hand-selected packages that are included in our VKS packaging. They are included as a value add, right? And then we have standard packages. And these are opt-in, some of the more powerful but also popular tools and Kubernetes centric tools out there that's within the catalog to make it super easy to deploy and consume. That's standard packages. Now, this is what, hey, these are value added packages and we want to package it. So this is what VMware thinks are full of value and customers can immediately get going with this. But there's an entire CNCF catalog of 200 plus projects that are built for Kubernetes that also work as part of this. So again, we're thinking platform engineering here, the theme for today's conversation. And we want to be able to say, we're going to be opinionated in building this path, but the tools and the capabilities that plug into that are actually going to be something that we can be a little less opinionated with, right? If we want to, because the core functionality is going to depend that I have to deliver on this path is going to depend on the mission or the application. So this all comes to what I said about a half hour ago, I think, about one platform. In this conversation where we have two platforms, we got to figure out, right now, a lot of you are dealing with like, okay, I have my app platform, let's just call it OpenShift, and I've got my VMware or VCF or vSphere platform for everything else. The conversation of the one platform comes down to this. Do I move my Kubernetes infrastructure to VCF and take advantage of exactly everything else? Or, meaning Kubernetes on top of my gold standard of hypervisors and everything else I know for 2 decades of vSphere? Or do I make the decision to move my VMs over to OpenShift, to running VMs inside of a Kubernetes runtime on top of KubeVirt and see what happens, right? That is, I'm being facetious, but this is a decision a lot of customers are having to make today, because there are two major players that are having these discussions, and it is Red Hat and VMware. So the decision is there, and what we are here to do is, and your teams and everybody you interact with at VMware, is to compel you to understand what it is VMware offers. Anyway, one platform. So you've got your vSphere. Everybody here knows what that is. And then we've got this, what we call the supervisor, which is a service, and it is essentially the Kubernetes control plane. And this is where your primary point of interaction is for all things Kubernetes and Kubernetes APIs. It is that control plane so that my DevOps team and GitOps processes and my platform engineers all interact with this control plane. And through that control plane, I could manage everything from my applications to my deployments and the fleet management to the underlying compute, storage, and networking infrastructure, which is all now adopting that Kubernetes declarative API, which is super cool, right? Then I've got containers as a service, or CAS, right? These are individual containers. Instead of running them on Docker, I'm running them in one consolidated platform on top of vSphere. And then my VMs. Now, these VMs are special. These are part of the VM service. So they're VMs for all intents and purposes, but they sit on top of the control plane. That means that my pipelines and my GitOps practices and my CI/CD and all of those things can follow the same exact processes, same exact APIs, and roll out VMs, Kubernetes, and containers alike, right? So I am declaratively consuming, managing, operating, and lifecycling virtual machines side by side with Kubernetes clusters and pods and containers. And that's pretty significant, right? And then we talked about our hand-selected tools that we include as kind of a value add to get things going pretty quickly. But of course, our storage operators, our CNIs for networking, all of those exist. And while we are opinionated in what's out of the box, we've opened the platform up so you could, so our partners, like for CNI, for example, you could bring in Cilium, you could bring in Calico, you could bring in Tigera, you could bring in these other partners that plug into your CNI so you can deliver exactly what you want and build these golden paths and paved paths based on the needs of the mission. That's what all of this comes down to. All right. To wrap things up, I have a very long slide, but to wrap things up, if we were to break this down into boxes, right? As far as what it takes to build the platform engineering stack. So again, this is the framework for building the deliverable, which is the IDP, internal developer platform, so that I can get my developers and everybody consuming infrastructure and just deploying it. At the end of the day, it really shouldn't matter. I should bring my exact tools and exact services and exact APIs and Helm charts and so on, and just be able to point to here instead of there. And that's really the goal here. But if we were to break this down into a framework, because I'm sure some of you can appreciate that, you've got your infrastructure and shared resources. We will be opinionated here. This is where vSphere lives. vSAN, NSX, and obviously the compute platform. The platform services, a lot of this is modular, right? It's composable. It's software defined, and CNCF and the open source community plays a huge role in that. But again, we can be opinionated if that's what a customer prefers, right? The developer experience, not one of those things that you think developer experience and then you think VMware in the same sentence. Historically, that has not been a thing. Raise your hand if you agree. It hasn't been a thing. We've tried to make it a thing, but it hasn't been a thing. Today, it's a thing. And I will have a much deeper conversation for anybody who wants to have that conversation. The developer experience, keep in mind, is about which tools plug into VCF as the platform, as that substrate, not necessarily using VCF automation as your primary developer interface. Now, 5 years ago, I told you that's absolutely what you want to do. Today, that's not necessarily the case, right? And that's not how VCF is positioned anymore. But anyway, developer experience, your self-service portal, these are truly the developer components, not an admin UI that we want to force feed the developer. So keep that in mind. Now, of course, the developer experience could also be a command line or nothing. It could be Argo, bringing in my pipelines. It could be just Helm charts. It could be a Git commit. The developer experience is up to the developer. What happens when that Git commit or when that code is committed is what the paved road and what the platform engineers are actually delivering here as a product. Okay. So then we have gold standard and governance and controls and security. But of course, all things are off the table if you can't get this right as part of platform engineering, because it'll never roll into production. And so every step of the way, you can call this zero trust, right? Every step of the way, security and compliance need to, follow the path and be embedded in every single um, point, right, from code to production. And measuring our outcomes, operational excellence, how we respond to issues, all of that's also in this in the IDP. It's baked into the golden path, all for the sake of deploying an app, right? All of this is for this app. Now, I told you VMware is a whole lot less opinionated than we used to be, and that is, I mean, that is so true, and it's actually quite refreshing. But at the end of the day, when you're looking at mission critical and you want to build a rock solid platform or deploy or make available a rock solid platform that you know is compliant, you know will pass your hardening requirements, you know can be deployed completely isolated and air gapped and can be and is up for the mission, right? You want to be able to look at a platform like that and say, man, if I could just put all my workloads on there, I'm good to go. Yes. The next thing that you're going to ask yourself is, can I bring my tools that my developers are insisting have to work with this? That's where we've now evolved and we can say yes, right? So we've got this framework here. We're going to be opinionated in some cases, but at the end of the day, because of the architectural decisions we made, because of the conformance of our Kubernetes infrastructure, we are, Kubernetes project conformant, upstream conformant, and compliant, meaning if it runs on Kubernetes, it runs on VKS, it runs on this environment. So bring your tools, your developer experience, whether it's Backstage or CLI, right? Or your API gateways like Kong and others, right? Your GitOps tools, all of those. What you're immediately gaining, though, is something very different in this environment than if you were just piece all this together. What you're gaining is the conformance and compliance of the platform that is now getting shared up the stack. So my developers can bring their tool of choice. They can develop against the APIs that now I expose, which are all conformant Kubernetes declarative APIs, and I can consume VCF however I want to, or with whichever tools I want to consume it. But I know as the platform engineer, as the architect, as InfoSec and CISO and all of these other folks who want to throw their hat in the ring, I know that all of this is now aligned to the mission, aligned to the enterprise. And that is what we're bringing to the table. That is what's different between this and your other on-prem platforms, and of course, your public cloud platforms. Okay. So yes, we are definitely taking advantage of the position vSphere has as this gold standard in the enterprise, and applying that to the wild, wild west. And that's essentially what's happening here. It's the best of all worlds, in my opinion. So with that, VKS, the vSphere Kubernetes service, just think of that as an extension of compute. It is infrastructure. It is not a DevOps or developer tool. Kubernetes is infrastructure. Okay. From the API and the control plane on up, that is where your dev teams, your platform teams, and everybody interact with. And that is essentially what we're delivering here. You gain a unified platform. You gain that self-service, however that self-service wants to be done. You gain fleet management of Kubernetes in ways no other private cloud platform does. Challenge me on that all day long. You've got your declarative API, which once you start using, you'll find it very difficult to jump back into a UI, right? It's pretty great if you haven't experienced it yet. And then these interfaces, but most importantly, this wholehearted adoption and embracing the CNCF community, I think is the smartest thing we've done in all of this. And I think it benefits our customers and the mission pretty broadly. So with that, I'm almost right on time with 3 minutes, which is a miracle. So Rob, I will send it back to you. Did those questions come in or any other questions come in?
Yeah, I don't see any questions. I don't know if anyone else, if anyone has any, put them in the chat, please. We'd be happy to get to them. Uh, Jad, I think you walked through pretty well the value proposition, the history. I definitely learned a handful of things, so thank you very much. And we are almost right on time, so very well done, sir. Any questions from anyone before? Let's see, very helpful. Thank you, David. We appreciate the feedback. Um, we can certainly go deeper into some of the features and the functions. I think as Jad was calling out, maybe do some demos with VKS and things of that nature, if that would be helpful. Maybe get into a 2 or a 300 level view.
Yeah.
We sort of purposely wanted to start the series off by just level setting, and we have a handful of ones we're doing around enterprise security. We're doing private AI, so we're going to start them at the 100-ish level, maybe a little, deeper, and then get into sort of the higher. So, um,
I will say, just this morning, actually, we've been doing this Kubernetes upskill from VMUG or with VMUG. So if you're not a VMUG member, become a VMUG member. But it's a free webinar. We're doing multiple services. Today was session 2, and for the first half of this day, more than a half of the day, um, I presented something similar to this, but then we dove into CI/CD, integrating Argo, architecture of VKS, and went a lot deeper. Me and 3 of my colleagues, and then the previous session was more of the introduction of VKS, and there's demos in all of these sessions. The playback is available almost immediately, I think, even today's session. So if you want to dig a little bit deeper or a lot deeper, we've put out so much content. I've blogged on this topic. This is where I spend the majority of my time, but also on the IDP, all centered around VKS and Kubernetes. Um, but but do look up that Kubernetes upskill. I think that's an awesome series. So session 2 just wrapped today, and then we're going to schedule session 3.
Perfect. We are right at time now, so we'll be respectful of everyone's time. Jad, thank you. You're a scholar and a gentleman. We definitely appreciate it. Great job. Thanks everyone for tuning in. We will see you on future webinars.
Thanks, Rob.
Simon,
Thanks
thank you,
all.
sir.
Have a good one.